our second advanced training session for Business Objects. This time we will discuss how to write effective queries. Our focus will be on how to use the tools in the query window to pull the data we need in order to generate our reports. Remember from our earlier model of our data system that Business Objects takes data from the CROA operational data store and organizes it into universes of related data. A query is how we pull data from the universes into our design tool. This is a critical intermediate stage in report creation. In our previous training, we described the 10 generic steps in creating a Business Objects report. In the first 6 steps, we really didn't do much in terms of generating a query other than dragging and dropping fields into the Report Objects panel. Today's training focuses on step 7, where we actually build a full query. For new reports, the query panel will open as soon as the universe is selected. In existing reports, we reopen that panel by clicking on the Edit Data Provider icon within our report. Let's take a quick tour of the elements in the query panel. The Results Objects panel is where we drag and drop all of the fields we later wish to use in our report. We don't have to actually show all of these in our report, but if we want to work with them, say by creating a variable based on a field value, that field must be in the Results Objects. The Query Filters panel is our primary focus today, as it is the area that you will be most involved with when generating reports. You can use fields for filtering the data in this panel without having to have them in the Results Objects panel. The Data Preview panel is a quick means of checking on your filters without the delay caused by a full query run. This is an optional panel and can be replaced by the Scope of Analysis panel or left off the screen entirely. We'll show you how to do that in a moment. The Data Outline panel displays the tree directory structure of the universe along with the fields in those folders. Most important to increase your efficiency in creating reports is the search box. You can enter keywords here and quickly reduce the displayed fields into only those most likely to be what you need. This panel is the source of the drag and drop fields for the Results Objects and Query Filter panels. The Query tab allows you to name each query and quickly move between queries. While naming your queries isn't required, it is good practice and will help others understand your report more easily. Query 1 doesn't tell a reader much about what you're trying to do, while Active Student Selection does highlight your query's purpose. The panel toggles allow you to control your work area. You can open or close Results Objects, Query Filters, Data Preview, and Scope of Analysis panels. A maximum of 3 panels can be opened at a single time. The Add a Combined Query opens a window in the bottom left that will allow you to combine 2 queries into a single result. So if we had 2 queries, A, the courses with enrollments of over 50% women, and B, the courses with enrollments above 50% Hispanic, our choices would look like the following based on the combination we select. The 3 combination options are Union, combined result for both queries, provides a list of all courses with mostly female students, and all courses that primarily had Hispanic students. A course that would meet both conditions would only appear once. Intersection only provides results that are common in both queries. This would list all courses that both had a majority of students being women and also a majority of Hispanic students. Note, this doesn't mean Hispanic women were the majority. These are 2 completely separate queries. It is possible that a course was 60% female, but all of the males and just over 1/6 of the females were Hispanic. And minus provides all the results from query A that do not appear in query B. This provides a list of all of the primarily female courses that weren't also primarily Hispanic courses. It is a good idea to write both queries individually first to make sure they're working properly before attempting to combine them. Query properties isn't really necessary in most cases, but there is one important use for this screen. If BusinessObjects keeps providing a pop-up asking your report viewers to indicate which context they wish to use when running a report, you will end up with confused users and potentially incorrect data. You can remove that option screen by unclicking the Reset Contexts on Refresh option. That way, the context you choose when writing the query will remain in place. The script viewer is also rarely used, except for power users who know all the field names and want to hard code the SQL queries. Still, it is a handy means of seeing exactly how the data is being pulled from the universe. If you make any changes to the code, you can validate it using the button provided. The controls for the Results Objects panel allows you to insert a quick filter, remove the highlighted object or all the objects in the panel, as well as moving the objects, fields, up and down in the list. The controls for the Query Filters panel contain some important options. The first is Add a Subquery, which places a query panel inside the query panel. For advanced users, this is a way to write more complex filters. The subquery is run first, and then its results are used as a filter for the larger query. Again, good practice is to try out both queries individually first and then combine them. The Add a Database Ranking option allows you to create reports that provide a unique subset of a query, such as the top 5 courses with the largest enrollments or the bottom 20 courses with the fewest historic enrollments. The middle filter list controls allow you to remove highlighted or all filters or move the filters up and down in the list. You can also highlight and delete fields in these panels by using the delete key. The final control, Add a Nested Filter, allows you to connect filter fields with and/or relationships. The and relationship means that all of the filters at that level must be true for the record to be selected for the report, while the or relationship means that if any one of the filters at that level are true, the record will be selected. Now that we have seen our workplace for query building, let's examine the elements of each filter. Filters restrict output. They determine which records move forward into the report design phase and which stay in the universe. Each individual field brought into the query filter panel acts as a filter. The first choice after selecting the filter fields is to determine what type of condition must be met. Here you see the list of options. The pattern matching options allow you to use wildcards. So a condition of last name matches pattern of $% would provide a list of names whose first 3 letters are STR. Condition data is what the condition type is comparing the database value to when making the selections. A constant is a hard-coded value. Value from list allows selection of multiple values to be matched against. Prompt we'll touch on in a minute. The final 2 options are matching the database against internal values, either the results of another query, which must be run before this filter will work, or another field value in this query. For these options to be active, the type of condition must be equal to. Grouped conditions, the results of using the Add a Nested Filter option mentioned earlier, allows for very complex relationships to be described. Here, the filter is selecting data where the course current status is equal to A, or the course name starts with ENGL, and, if either of those 2 conditions are met, if the selection reporting term is less than fall of 1986. Only if the OR condition and the AND condition are true will the record be brought forward into the report. One powerful trick in query development is to use the prompt option for the condition data. This avoids the need for hard-coding values and reduces maintenance requirements for future runs of this report by allowing users to enter current value requirements. Prompt text can be modified either by typing over the default in the filter itself or by using the properties pop-up. Default values can be set as well as other options. Using prompts where possible is good practice. One important issue that may strike query writers is when their query returns two or more different result sets. This is why the data preview panel is so helpful. If on the right of the panel you see a drop-down box showing result 0, then BusinessObjects has found ways to connect some of the data you're asking for, but no single way to connect all of the data in a single report. If you didn't use the data preview panel, you'd see this in the design phase because BusinessObjects would create a unique table for each of the results on the screen. By using the Query Script Viewer, you can see the coding created by BusinessObjects to try to meet your request. As you can see, these two are completely different scripts. The trick is to pick one of the two queries, identify and remove any unique fields from the Results Objects panel, and refresh the query. If the multiple result pull-down disappears, you can then write a second query to capture the missing data. Just make sure that you have a common field between the two queries. In the design phase, you can merge these two results to get the single table you were seeking. We'll cover that in another training. What makes a query effective? What makes it run faster? In general, the criteria for a good query is that it processes the bare minimum number of records, uses the least number of filters, minimizes the use of nested or calculated filters, uses only the fields needed, and actually gets the results desired. There are some cases where the client wants both big and little pictures of the data, wanting to have the institutional data that can be drilled down to a particular department, for instance. That query will be slower and larger than one just focused or filtered on that department, but that's what the client wanted. In these cases, you will have to build in either drill downs, report filters, or input controls during the design phase. More on that in another training. Let's get practical. How do we go about setting up these filters? As always, you need to think through your data. Decide what data needs to stay and what data you don't want to include. Write the data question out and parse it carefully. Here you see a typical question asked of a query writer. It seems fairly straightforward to the person who wrote it, but when the query writer examines it, some key issues arise. We need to focus on students, ethnic data, and enrollment data in the particular math courses over a given amount of time. And specifically, the writer needs to address the following, often with the aid of the client. Because the percentage requires all students, I don't need to filter on students. Maybe. Do I need just those with grades? Grade filter. Or just those who didn't drop? Status filter. What is remedial math? Is it a list of certain courses? In list filter. Or is it courses below a particular number? Course number less than filter. What are the last 2 years? Academic, reporting, calendar, or fiscal years? If this report is going to be used in future, perhaps a prompted filter to increase the ease of maintenance? Let's actually give this a try, shall we? We will need to ensure we have student ID values and the Cal MIS ethnicity fields in the results objects, so we can count students and generate the percentages. Based on conversations with the client, we are only seeking data on students with an active status in the class, A or N codes, and we define remedial math courses as those with a course number below 60. We find out they are interested in academic year data and plan to use this report in future, so we'll be using a prompt for the year field. Knowing that, we're ready to open BusinessObjects and give this a try. We start a new query and select the student universe because we're dealing with student demographics and enrollments, both areas we know are in that universe based on the folders contained in it. We pull our standard student ID field so we can calculate at the most discrete level. We then use the search box to find the Cal MIS ethnicity field and bring that into our Results Objects panel. We know that the status of the enrollment is somewhere in the student enrollment folder. We type status in the search box and bring it out. We select it and move the object into the Query Filters panel, but not the result objects. We don't want this in our report. We just want to use it to filter out those who weren't actively enrolled in the courses. We do this by selecting InList as the condition type and the values A and N, which we learned from our client meant active enrollment. We search for academic year and put it in the filters. Choosing prompt as the type, we modify the prompt text by simply clicking in the box. Now we try to find the fields we need to filter for the course. Course name looks good, but we see it contains both subject and course number. That might be helpful in the results if the client decides to ask for a breakdown of the data by course, highly likely. So we go ahead and add that to the results even though it hasn't been asked for as yet. A bit further down the list, we see course subject. That's an excellent way to filter out only the math courses. We grab that and put it into the filter, choosing math as our subject of interest. Now we just need to find the field for course number and we will be all set. But it doesn't appear to exist in the student enrollment folder. Generally, we like to stay in single folders if we can, but we take a risk and search and find a value for course number under Program Required Courses. We grab that for our filter and choose less than and enter a constant value of 60. In reviewing our query, we realize we'll need the academic year in our report, but we forgot to include it in the report objects when we found it last time. We find it again and bring it in, as well as its description, into our report objects. Now is the moment of truth. We refresh the data preview. We select our years for the prompt and await the results. At first they look good, but a quick scan reveals that, as feared, our course number filter isn't working properly. We have many enrollments in classes whose number is above 60. All is not lost, however. We did find the course name field earlier. We bring that down from the results objects and decide to use an InList condition type and merely select all of the courses whose number is below 60. While not the best solution, new remedial courses won't be caught by this filter if they aren't on the list, but it is a workable one. Running it again, we now have the result set we want. We go ahead and run the query. Our data ends up in the design window in a simple table with the results objects in the order we gave them in our results object panel. Clicking on the user input icon, we see our prompt with the replacement text we created. Notice that the multiple values are separated by semicolons. This is something we need to train our users about, how to enter multiple values in an input box. But for now, we're finished with our first effort in the query, and we can move into the design phase next time. Thank you for your patient attention, and we hope you enjoy your voyage into query creation in BusinessObjects. Have a wonderful day.